Hello everyone, our focus for this video is the sine rule, right? Now, before I write what the sine rule is, I'm actually going to derive the sine rule and show you. So let's say you have an equilateral triangle, right? Hopefully this is. Now what do we know about equilateral triangles? We know that all sides are equal, right? So assume that this is drawn correctly. This is not drawn to scale, so all three sides are equal. All three angles are equal, right? So this is 60, 60, 60, and these lengths are the same. So let's put some letter on it. Let's say that this is A here, and this is B, and this is C, right? What if I want to label the sides of the triangle? How do I label the sides of a triangle? Here, this is A, right? So, the side that is opposite to A, or you could say angle A create the line BC, right? Which means that because the side that is opposite to the angle, it's the common letter of that angle. So this is angle A, this side is opposite to it. So that means this is common B. Clear? And the same idea here, this is B, so this side is common B, right? And this side is C, so this side is common C, alright? Let's say that you want to determine the altitude of the triangle, right? Or the height. And you want to pick any one of the vertex. I'm going to pick the vertex B here, and you draw a straight line touching this side. What the altitude does, it splits the triangle in two equal parts, creating two right angle triangles, right? So now I have two right angle triangles. Let's call this altitude here H, right? So we know that this altitude here, this is just H. So this line, and where it meets this line, let's say that this is the line, this is D, right? So this part here is point D. Point D. Alright? So now we have two triangles on the board. We have ABD and we have BDC. Right? Now since we're talking about the sine rule, right? Let's say we want to take the sine of A, which is this angle here. The sine of A, and we also want to take the sine of C, which is this angle here. So we want to take the sine of these two angles and see what they're equal to, right? Now, if we want to take the sine of A, we have to consider the right angle triangle ABD. So that's right angle. So if we consider in the triangle, and this symbol means triangle, ABD here, ABD, we have two measurements, right? We have the altitude, which is H, and we have the hypotenuse, which is C here. So what is sine? Sine of A. So sine of A would equal to the opposite to this angle here, which is H. So that's just H all over C, right? So that's what the sine of A is equal to. But what does this imply really? We could make H a subject of the formula, right? By just multiplying both sides by C. So if we multiply both sides by C, we basically get C sine of A is actually equal to H. Clear there? That's if we write it in terms of H. Now, look, what about when we are taking the sine of C? Which triangle are we going to take into consideration? We're going to take triangle BDC. So triangle BDC. Alright, BDC. If we take triangle BDC and we want to take the sine of C, the sine of C, which is the angle here, is equal to the opposite. What's the opposite? That's just H, right? Over the hypotenuse here, which is just A. So that's just A. But what does this imply? What if we want to make H the subject of the formula? We just need to multiply both sides by A. So if we multiply both sides by A, and this side, we're going to get A sine C is actually equal to H. So now we have both of these technical equations in terms of h, right? But what does this mean? If h is equal to c sine a, and h here is equal to a sine c, that means a sine c is equal to c sine a. So we can write that, right? So we know that c sine of a is therefore equal to a sine of c, right? Now, let's say I don't want this sine a beside this c here. I don't want the sine a beside this sine c, and I don't want this sine c beside this a. What can I do? I can divide both sides. I can divide both sides by, right? And it's an equation, so it's legal to divide both sides by whatever you want. So I can divide both sides by sine of a, sine of c. And I'm going to divide this side by sine of a, sine of c. What do you think is going to happen to this side? I have a sine of a in the numerator and I have a sine of a in the denominator. So this sine a cancels out this sine a here. What am I left back with here? I'm left back with c over sine of c equal to, I have a sine c in the numerator and a sine c in the denominator. So sine c take out sine c. I'm left back with a over sine of a, right? So that's basically what this is equal to. So let me just write this part here to the top over here. So I know, and I'm going to write it the other way around. So I know that c over sine of c is equal to a over sine of a, right? Does this look familiar? Of course it does. Should ring a bell by now. Alright. Because I'm running out of space, I'm going to erase all of this. So now I have one part. Now, let's say I erase this altitude here in this triangle. Right? And I erase point D. And now I'm going to draw the altitude from a different angle in the triangle. And I want the altitude to be at point C here. So I'm going to draw a straight line from point C. So hopefully that's straight now. So this line is perpendicular to this one, so it creates a right angle triangle, right? The altitude, right? It's an equilateral triangle. So the altitude are always equal, right? So this altitude here is still h, right? Now, the angle that I'm going to focus on is no longer actually C in this case. I'm going to focus on taking the sine of B this time and the sine of A, right? And I'm going to see what that takes me. So here, considering now I have two triangles, right? And where this line meets, I'm going to call it point D just the same. So this is just point D. I know that this side is still, the entire length of this side is still common C, right? That's just common C, right? So here, I can now take the sine of A, right? What does sine A equal to? Sine of A is equal to the opposite. But what's the opposite side here? And I'm considering the opposite side is just H over the hypotenuse, which is just B here, right? You see that? And for you not to confuse, let me just tell you the triangle that I'm considering. I'm considering triangle. This is ADC. So I'm focusing on triangle ADC, which is this right angle triangle here. Right? So that's what sine A is equal to. But I can write this function in terms of H. So what does H equal to? H is therefore equal to B sine of A, right? Because you must multiply both sides by B and you get what H equal to. Now I'm going to consider triangle, and this means triangle BDC. So triangle BDC. BDC, right? If I'm considering triangle BDC and I want to take the sine of B, then sine of B is actually equal to opposite, right? Opposite over the hypotenuse. What's the opposite here? Opposite to this angle here, if you draw a line, you get this line, which is the height, right? Which is just h. Over the hypotenuse. Where's the hypotenuse? The hypotenuse is the line BC, which is just a here. So that's just a. But I want to write this equation in terms of h. So all I need to do is just multiply both sides by a. If I multiply both sides by a, h is equal to a sine b, right? Now, what you can do, if h is equal to b sine a and h is equal to a sine a, that means these two things are equal. So we can therefore say that b sine of a, b sine of a is actually equal to a sine of b. Alright? And I am going to divide both sides by sine of a, sine of b. And I'm going to divide this side by sine of a, sine of b. Now here, clearly, I have a sine a in the numerator, right? So this sine a takes out this sine a in the denominator, right? So all I left back with here is just b over sine of b, right? Equals to, I have a sine b here, so this sine b takes out this sine b. So I left back with a over sine of a, right? But this is just a sine rule, really. So this is now saying that b over sine b is equal to a over sine a. So I can put all three of them together, right? I already have sine a up here already. So all that is needed is a sine b. So I can say that b over sine of b is equal to c over sine c, which is equal to a over sine a. And if you put it all together, you get the sine rule, right? So I'm going to write this in alphabetical order, in other words. So I'm going to write a over sine of angle A is equal to b over sine of b equal c over sine of c. So that's basically what the sine rule is. So this is the sine rule. So the sine rule is a over sine a equal b over sine b equal c over sine c. But how is this rule useful? This rule is useful in terms of when you are given a triangle that is non-right angle. So the triangle must be a non-right angle triangle, right? So once you have a non-right angle triangle, you can ask to calculate a given angle, no, a missing angle, sorry. So you can ask to calculate a missing angle, or you can ask to calculate a missing side, but you would have to be given some information, right? So this rule is useful for that, right? Now, how do you know when to use this rule? Let me just give you one. One way you know to use this rule is when you have a non-right angle. Triangle, right? That's one way. So you use the sine rule when it's a non-right angle triangle, don't you? But what else do you need to know? You must be given two sides and an angle opposite to one of the known side. Right? So that's one condition in which you know when to use it. So you know the triangle has to be a non-right angle triangle. That's one case. Another case, you must be given two sides, that means the length of two sides, and an angle opposite to one of the known side. Right? That's one condition. And the third condition is that if you are given two angles, and a known side opposite to one of the known angle. Alright? So these are the three cases in which you know when to use the sine rule. Now, when to use the sine rule, there are three conditions that you must remember. One, it must be a non-right angle triangle. That's one. Two, given two sides and an angle opposite to one of the known side. Three, given two angles and a known side opposite to one of the known angle. Right? So these are the three cases in which you use the sine rule. Now, where x is, that's opposite to 40. So we can see that x over sine of 40 degrees is equal to this 2.6 here, which is equal to 2.6 over this sine 30 over sine of 30 degrees. Right? Now, ensure that you have your calculator. So what you can do, you can find what sine 40 is first, and then you find what sine 30 is, and then you solve from there. Or what you can do, you want to find x. That means you want x by itself. So what you can do is to multiply both sides by sine 40. So you write back what you have, which is x over sine of 40 degrees is equal to 2.6 over sine of 30 degrees. Now I don't want this sine 40 here, so I'm going to multiply the entire thing by sine of 40 degrees. Whatever I do to one side, I also have to do it to the next side, so I'm going to multiply all of this by sine 40 as well, degrees. Now, by multiplying both sides by sine 40 will cancel out this sine 40. So all I'm left back with is x, right? Here. And x here is now equal to 2.6 times sine 40. So this is now equal to 2.6 sine of 40 degrees. All of that divided by sine of 30 degrees, right? So x is equal to, now you can put all of this on your calculator, right, in one go. You can just put all of this on your calculator. So let me show you how you would do that. So what you would do, ensure that your calculator is turned on, and you will select your fraction bar if you have a calculator like mine, right? Then you put 2.6, you put 2.6 times sine of 40 degrees. You select sine and select 40, close the bracket. Use the arrow to go to the denominator here, and then you put sine of 30 degrees. And you press equal. So after you press equal, your answer is 3.34. And if we round that off to one decimal place, our answer is approximately 3.3, because 4 is less than 5. So our answer here is 3.36 centimeter correct to 1 decimal place, 1 dp. Right? And that's how you would use the sine rule to calculate the length of a missing side. Let's look at the second one. So now the second one, you're asked to find the side P here. Now you're given two angles. Again, we can apply the sine rule to say that P over sine of 108 degrees is actually equal to 21 over sine of 50 degrees. Again, let's just show a different approach in this case. Again, I'm going to go ahead and find what sine of 108 is. So here, sine of 108, so sine 108 degrees, that is just equal to, so first, I'm going to write back my P. So this is going to be P over sine 108 degrees. But what sine 108 degrees as a decimal is equal to 0.951. That's correct to 3 decimal place, right? Which is equal to 21 over sine 50. So I'm going to put sine 50 on my calculator. And sine 50 here as a decimal is 0.766, correct to 3 decimal place. So what you can do now, I don't want this 0.951 on this side, so I'm going to multiply both sides by 0.951. So I write back what I have, which is P over 0.951 is equal to 21 over 0.766. Right? Now I'm going to multiply both sides. I'm going to multiply both sides by 0.95. So I'm going to multiply this side by 0.951. And I'm also going to multiply this side by 0.951. 0.951 going to cancel 0.51, so I'm left back with P is equal to, I can simplify what is in the bracket here, or I can just do it one time. So this is 21 times, so this is equal to 21 times 0.951, all of that divided by 0.766. So P is therefore equal to, now I'm going to put all of that on my calculator, and this is how you would do it. Now you will select your fraction bar, you will select 21, put multiply by 0.951, all of that divided by 0.766, and you press equal. And that is approximately 26.07, correct to 2 decimal place. And if you round that off, that's just 26.1 centimeter, correct to 1 dp. Right? And that's how you would find the. So now, for this question, we have been asked to find theta and theta, right? So what do we know? We know the length of two sides. We know one angle, and we don't know one angle, so we need to find that. What can we apply? The sine rule. What does the sine rule state? The sine rule says that if you have the length of a side and an angle opposite to it, then you can see that this side, which is 9.8, is over this sine of this angle, which is sine of 70 degrees, is equal to this length, which is 8.8 0.2 over the angle that is opposite to it. Sine of the angle that is opposite. So it's sine of theta. Alright? Now, how are you going to approach this? There's several approaches that you can take, but let's use the simplest approach. All you can do is to put this side on your calculator to give you one value and get rid of the fraction. So you can see that that's just 9.8 divided by sine of 70 degrees. And that is approximately 10.43, correct, to 2 decimal place. Now this is equal to 8.2 all over sine of theta. How are you going to get sine of theta by itself? Multiply both sides by sine theta. So multiply this side by sine theta. Also multiply this side by sine of theta as well. Sine of theta cancel out sine of theta. All you're left back with is sine of theta times 10.43 is equal to 8.2. Divide both sides now by 10.43. So divide this side by 10.43 and also divide this side by 10.43. 10.43 cancel out 10.43. So sine of theta is equal to 8.2 over 10.4. But you can put that on the calculator and get one thing. So you can see that is just 8.2 divided by 10.43. And that gives you approximately 0.786, right? To 3 decimal place. What are you going to do to find the angle theta? Take sine inverse of both sides. So if you take sine inverse of this side, you're left back with theta is equal to sine inverse of 0.786. All you need to do is to put that on your calculator and you're finished. So you're going to press shift sine and then the inverse function will come up. Type in 0.786, close your bracket, press equal, and that gives you approximately 51.8 to 1 decimal place, 51.8 degrees, correct to 1 dp. And that's your answer there. And that's the approach that you will use to calculate an missing angle, okay, using the sine rule. So let's just look at the last example quickly. So now here we have the length of two sides, we have the length of one angle, we have the length of an unknown, we have an unknown angle, sorry. So here again we can just ratio the opposite side to the given angle, right? To this angle that is opposite to it. So here we can say that 4.8 over sine of 64 degrees is actually equal to 5.2 all over sine of theta. Alright? Again, because most people are not comfortable with working with fraction, you can put this fraction on your calculator. So that will give you 4.8 divided by sine of 64 degrees, which is equal to, this is equal to 5.34, correct, to 2 decimal place, which is now equal to 5.2 all divided by sine of theta. Now, how are you going to get sine theta by itself? Now you can multiply both sides by sine theta, right? Now, if you multiply both sides by sine theta, multiply this side by sine theta, and also multiply this side by sine of theta, then sine theta is going to cancel out sine theta. And on this side, you left back with sine of theta times 5.34, which is equal to 5.2. Because you are multiplying by 5.34 and you want to get rid of it, you have to divide this side by 5.34. But this is an equation. So because you divide this side by 5.34, you have to divide this side by 5.34. 5.34 cancel out 5.34. What are you left back with? This is the sine of theta. What is this equal to? It's equal to this thing over here. But you can put that on the calculator, right? So that's just 5.2 divided by 5.34. And what does that give us? That will give us a decimal which is 0.974. Correct to 3 decimal place, right? Then what do you need to do to find theta? Take sine inverse of both sides. So if you take sine inverse of this side, you're left back with theta is equal to sine inverse of 0.974. What are you going to do? Put this side on your calculator and you find the value of theta. So you're going to press shift on your calculator, press sine, and the sine inverse will come up. Type in 0.974, close your bracket, and press equal. And that gives us an angle of 76.9, correct to 9 degrees, correct to 1 decimal place. So that's those correct to 1 dp. And that's it there. That is how you use the sine rule to calculate an unknown angle. Thank you for watching and do enjoy the rest of your day.